Hello everyone, welcome to Debugging Doubts. Today let us understand about the paging concept in operating system. So why do we need this paging? So consider a kind of a 10 pages notebook, okay? So you have a 10 pages notebook and you have written something on it and you have torn the pages and you keep that notebook in some other location, okay? Now your second friend, what he does is he also writes some kind of content and he will also keep that in the same location wherever it is kept. So this time what he will do is he will not keep in the same location, okay? He will randomly he will keep mix with your paper too. So now how to sort this problem? So basically you will be thinking like if I mark every pages like the first page, the seventh page, the ninth page is mine in some other kind of notes, then you will clearly come to know that okay, these are all my pages and the remaining are his pages. So this is how the concept works. So now consider like you and your friend were two people, right? So they consider they are the two processes. So for each process, there will be logical address. So now let us consider about process one. Okay, this side you can see logical memory. Actually, it is not in this manner, but for representation I'm showing. So consider this is process one, and you have like you have divided the process one into four pages. Okay, page zero, page one, page two, and page three. Now in that pages you will also have some kind of lines, right? In every notebook you will have some lines. That same thing you understand. So there will be zero offset, one offset, two offset, and three. And page one also same thing. Page two same thing. Okay. Now what the CPU does is whenever it is executing, it will say okay, process P1, give me your page 1 and offset 2. Like from page 1, give me your second line. So second line is data G, but CPU doesn't know. So it is stored randomly in this physical memory. How it will fetch? So I will say CPU will request page 2 and offset is 3. Okay. From page 2, give me the third line. So whenever it requests, so you can see logical address is composed of two things, that is page number and offset. Page number, as I said, it is the partitions and offset is the exact line of your data. So this data, first thing CPU will do is find in the page table. That is what I gave in the example. Your friend must write somewhere in the location that these are all my related pages and remaining are others, right? So same way, there would be a page table like a register. It will try to find the page number. So whenever it requests the logical address, first thing the page number is searched in the page table. So you can see two. So from this two, you will try to match the frame number. So I will show that. So 2 is found and try to match the frame number, and this 7 will be stored in the physical address. So whenever you CPU request from logical address, you can't directly find in the physical memory. You need to find first the physical address. So from 2 you got 7, then you store the 7 in the frame. So now what is the value of offset? So for offset there is no kind of page table, right? Actually, think the same example. So your friend has written some kind of information on the second line, okay, in fourth page. He has written some kind of message in the second line. So whenever he shuffle in some order in the database, then still the second line will be the having the same content, right? So the offset will not change. So that's why here also the offset will not change. So same offset will be taken here. So now we got the physical address, that is 7 and 3. So 7 it is 111 and 3 it is 11. So total is 5 times 1, right? So now this address is taken by the OS and it tries to find it in the physical memory. So that is this frame 7. So it has the page 2, right? We have requested for page 2. So it will try to find the page 2 in the frame 7, and from here you get the data, and that is given as L. So it will try to fetch the data. So this is how the paging works. Now let us understand. So what is TLB? So now think the previous process. What we have done, we have directly taken the logical address and we found it in the page table, and finally we generated the physical address, and from physical address we can directly fetch from the memory. So what about there will be a long number of page table, so it will take lot of time, right? So if you have frequently access to same page, then it's better way to store in some cache memory. So for this purpose, now let us try with an example. Okay. Okay. Now the I have set the page 4 and offset as 15. So CPU will uh, ask the OS to give the page 4 and offset 15. But directly you can't take the logical address and find in the physical memory. For that purpose, uh, you need to create a physical address. So first OS will directly ask the TLB cache. So there is nothing, right? So page number and frame number is not present. So then if nothing is found, directly it will ask the page table. So page table, there is value, right? For 4 it is 13. So 13 will be stored in the physical address, and the offset is the same 15, and finally you find the value. So I'll generate that thing. See, the same thing. So first thing, CPU took the value 4 and 15. So it requested for page 4 and offset 15. Found in the TLB cache, there was nothing. So it found in the page table, and the same value was reflected in the physical address. And finally, using this physical address, you found the data. So what suppose if I generate one more time? See, this time the same page number was asked, and it tried to find in the TLB cache, and it found that 4. So it already have the 4 and the frame number is 13. Instead of going the 4 and 13 here in the page table, directly it found and entered the 13 here, and offset value is the same, and directly it found it. So no need of looking at the page table. So directly you can access the TLB cache. So this will be the faster access than the previous one. So this paging concept helps to reduce the external fragment. So external fragment is uh, there will be small kind of chunks of available space, but you can't store programs in that location. So then what you do, you try to divide the program into small chunks and store wherever it can be fitted. So there is no kind of contiguous memory, but you randomly store anywhere, and until and unless you have the page table, then you are safe. So this was all for today, and if you like my video, please like it, share it, and subscribe it. Thank you all, guys.